Algebra, Unit 3, Lesson 9, Notes 9, Analyze and Compare Functions. You can compare slopes and y-intercepts for tables, graphs, and equations of linear functions. Letter A. The three different linear functions below are represented in three different forms. Which function has the greatest slope? Which has the greatest y-intercept? So in order to figure that out, we need to find the slope and y-intercept for all three functions. Let's look at function number 1. We have a table. To find the slope, we need the change in y values over the change in x values. Again, pick any 2 points. I tend to like to deal with positive numbers, but you can use whichever 2 points you want. 3 to 9 is plus 6, and 3 to 6 is plus 3. So our slope, which is the change in y over the change in x, 6 over 3, which is 2. To find our y-intercept, I need to plug into the slope-intercept formula. Y equals mx plus b. I'm just going to pick the bottom point, no reason. I like dealing with positives though. 9 is the y value. 2 is the slope. 6 is the x value. And I don't know b. 9 equals 2 times 6 is 12 plus b minus 12. Again, negative 3 equals b. I don't need to write an equation. I'm simply just interested in the slope and the y-intercept. So the slope is 2. The y-intercept is negative 3. Let's look at function 2. This time we're given a graph. To find the slope, I need to know the rise over run, or change in y over change in x. So slope equals rise over run. Pick any 2 points on the graph. I will choose this point right here. Let's make it a little bigger. I will choose this point and this point. To figure out the rise over run, I'm finding directions. So I'm going up 1, 2, 3. So the rise is 3. And I'm going right 2. So the run is 2. So our rise over run is 3 over 2. I could leave it as a fraction, or just for comparison reasons, I'm going to change it to a decimal. Divide it out, I get the slope is 1.5. So the slope is 1.5. To find the y-intercept on a graph, that actually is quite simple. I just look to see where my line, right here, intersects our y-axis, which is right here at this point. So right here is our y-intercept, which is at b equals 1, 2, 3, negative 4. So there's the y-intercept for this function. Function 3, well, I need to get it in slope-intercept form to easily find the slope and y-intercept. So I'm going to subtract 3 from both sides. I need to get y by itself. So I have 2y equals 3x minus 3. I'm going to divide everything by 2 to get y by itself. Y equals 3 over 2x minus 3 over 2. Now again, I could normally leave it like this, but for comparison reasons, I want them as decimals. Y equals 1.5x minus 1.5. So the slope is 1.5, and the y-intercept is also 1.5. Okay, so now let's take a look at our slopes and y-intercepts. Which function has the greatest slope? So which function has the largest slope? Function 1 has a slope of 2. We have a slope of 1.5 and a slope of 1.5. So I'm going to say function 1. Which has the greatest y-intercept? We have negative 3, negative 4, and this actually should be negative 1.5, noticing my typo there. negative 1.5. So our greatest y-intercept is actually in function 3. Let's put some context to it. The total cost of renting a lawnmower from Lawns Incorporated and Green Lawn are different. Each company charges an initial fee and an amount per hour. In each of the following, X represents the number of hours and Y represents the total cost. Which company charges more per hour, and explain. Also, which company charges a greater initial fee, and explain. So we need to find the slope and y-intercept again for both of these. So pick any 2 points. I'll pick the first two. Our slope is going to be change in y over change in x, which would be, I have plus 9, and here plus 1, so 9 over 1, which equals 9. Our y-intercept, I would say plug it into your y equals mx plus b formula. However, the one thing that's great about tables is sometimes they actually will tell us the y-intercept. When they have an x value of 0, the corresponding y value is the y-intercept. So this worked out nicely, and that our y-intercept is 20. Over here for Green Lawn, it's already in slope-intercept form, which is great. Our slope is 10, and our y-intercept is 15. Now, x represents the number of hours. So this slope in both of these represents the charge per hour, how much it costs per hour. And y represents our total cost. So y is our total cost, which means our y-intercept, if it's not the total cost, it's not the charge per hour, it's not the number of hours, it's going to represent an initial fee. Okay? So no matter what, the company will charge an initial fee plus an hourly rate. So which company charges more per hour? We were looking at your slopes. In this case, Lawns Incorporated has a slope of 9, which means they charge $9 an hour. Green Lawn charges $10 an hour. So the company that charges more per hour is Green Lawn. Okay, and our explanation is they charge $10 versus the $9 that Lawns Incorporated charges. Okay, that's our explanation. Which company charges a greater initial fee? So again, we're looking at our y-intercept this time. Lawns Incorporated charges $20 as an initial fee, and Green Lawn charges $15. So the company that charges a greater initial fee, that would definitely be Lawns Incorporated. Okay, and that's because they charge an initial fee of $20 versus Green Lawn that charges $15. Okay, go ahead and try the rest of these problems on your own.